So yesterday in the previous class, we had seen about the what is variant approach for process planning and what is generative approach of process planning. Okay, and now let us see about, as we have seen yesterday, we have multiple softwares available for process planning, whether it is based on variant approach or on generative approach. So we'll see some of them. We had seen yesterday about CAM 1. Okay, so today we'll see a few more. Okay. And yes, so the other one that we have is about MIP Line or the multi-cap. So both are developed by the organizations for industrial research, okay, which actually works on the variant systems. Okay, right. So a code has to be written for every part, and they can be edited, like where for every part there's a they have to identify which family do they belong. And similarly, for which a standard template will be available, on which they can input the data, or they can retrieve an existing file and they can edit that particular file according to the new part that is to be manufactured, right? So that's how this multi-cap is going to be done. So the MIP is the next one, that is the MIP actually works on the basis of the generative approach, which has got very much details that we can have, which gives too much of flexibility also in the generative approach techniques, right? So this was developed by the software division, department having in the Institute of Advanced Manufacturing Science. So yes, so first thing is that they extract the module in MIP. So whatever this the CAD file, that is what is going to be extracted. So features from that, what are the dimensions, whether there is hole, fillet, and what is the material that it has been made up of, right? So all that things are going to be captured or identified by the software itself. Okay, right. So then comes the they have to use the inference rules that is already preset in the software. So that is going to determine the machining methods and their orders. So it is also going to take about what is actually running in the industry, that is what are the products that they are manufacturing, and what parts are they manufacturing at present. So still to complete that, how long does it take? So it would have been already calculated. So if this new part has to start manufacturing, it should give us the it should, based on the when is the current order getting over, and when is it possible for this new part to start manufacturing, where we can start manufacturing for this new part, and then how many machines to be allocated, what is the start date, duration, machining time for each part. All these data will be present in these softwares, right? So that is why, based on the layout of the industry and what are the types of machines available, these things will be calculated. That is the amount of time required to start, to complete the entire manufacturing of that particular part. How many pieces have to be manufactured should be the input data that should be given by the user, right? And how many machines can be allocated based on the availability, right? Which also has the sub-dependent as what is its machining capability, and then is all about the duration that comes into picture, the number of pieces, and how long does it take for one part to machine, the most important. Yeah. So yes, okay. So it's also going to give the, that's it. Basically, it's going to take out the necessary data for the milling operations or turning operations, making a hole, right? Counter boring. So all that features are going to be identified by from the CAD model, and based on that, it is going to capture these details. The software is going to capture these details and allocate those particular operations to that relevant machines. Okay, automatically, but it has to be cross-verified, right? Yes. Okay. So the next thing is about the ICEM. That's another software that was developed in the product and design engineering, University of uh, 20 in Holland. Right. So yes, this is first going to read the geometric model in the ASCII format. Okay, sorry, in the ACIS format. Okay, or the step format, and extracts the machining features. Then it is going to set up duration, cutting time, cutting parameters, what tools are to be utilized depending upon the if the surface finish details are given. Based on this, it is going to capture these details and give the relevant outputs for such features. And similarly, it can also generate if the CNC machines are connected, then it is also going to generate the CNC programming for this. Right? Okay. So this is about the process planning approaches and the just an introduction to the different softwares that is actually being used. So actually in practice what happens is that these softwares are used in the production department, and for this when the software is going to be initially uh, incorporated into that particular industry, details such as what is the layout of the machine, what are the types of machines that is present, what are their capabilities, all these details will be uh, should be input to this software. So only based on this, it is going to take up the data, right? So it is going to run the logical process whenever a part has been coming for process plan. So without these things, the software can only give a rough figure of how the process planning and how the part can be manufactured. So, okay. So yes, so next we shall go for uh, uh, the next thing, that is the group technology, because in the previous headings till now we had seen about the parts are classified uh, into families, and will have a code. So now we shall see a little bit in depth about the group technology, how it is being done, how the parts are going to be identified, and how they are going to be grouped into families. Yeah. Yes. So now the first thing in group technology is there are thousands of parts. So these things have to be uh, to be grouped into particular family. So say for example, nut and bolts, and then for that we can also include the washer also, because this is going to be one set of family. So wherever a nut and bolt is going to be used, suitable size of washer also has to be used, right? So so all these three things can be put into one family. Next thing that comes into picture is the pistons. So first thing is, if we are going for an automobile company, for an example, if you take up an example, right, then they have different models uh, that they have got, right? So if it is a two-wheeler, they will have a 100cc bike, 125cc, right, 150cc. So the pistons used for these are different, but all of them are the pistons. So all these pistons can be grouped into one family, right? So similarly, the engine blocks for these, for a 100cc bike, for 125cc, for a different variant, right? So even that can be grouped into another family. So we can retrieve these things based on the codes, right? Okay, so that is how the grouping takes place. So that is one way of grouping actually. So the definition for group technology is like this. So group technology is the realization that many problems are similar, and that by grouping similar problems, a single solution can be found to a set of problems, thus solving time and effort. So all we are going to see here is what does this statement say is about they are having similar type of problems. They have many problems and all are similar. One way or the other, they are similar. So we group these similar problems, and once we group it, since they are similar, the solution is going to be almost the same, not much different. So we can save a lot of time and effort. Okay, so that is what is the definition for group technology. Yes, so the objective of group technology is what actually? We have to first create a database of similar parts. It can be based upon the design, the process, the shape, right? Anything like this, right? And actually even also multiples also, any of the options, okay? And create a database for this, so that if it is going to be in the uh, for creating the design procedure and manufacturing for such things, then the steps involved are going to be the same. Say for example, if we are going to have a nut and bolt to be created, first thing is going to be the it has to go for the material, the length, head of the bolt, right, nut, thread length, type of thread, and pitch. So all these features are going to be common, right? So, so the procedure for this, whether we are going to manufacture a smaller nut and bolt, right, a 100 length nut and bolt, okay, or a 50 nut and bolt, the procedure is going to be almost the same, right? So we need not have to create these procedures again and again, wasting time, right? So steps are almost going to be similar for this, right? So it has to go in the same sequential order, even if the uh, the part is going to be different, but belongs to the same family. So thereby, from the manufacturing point of view, this is how it is going to be advantageous. So this is also used in the assembly shop also, right? So to assemble the parts, it's easier for us to identify the parts. So whenever we need a nut and bolt. If it is placed in particular baskets, all M10 nuts and bolt in one particular basket, M12 in another basket, retrieving these things is going to be an easier one. So for this, all we need is about the uh, is the storehouse, which has to group all these parts, okay, and store it in separate bins or separate groups where it can be retrieved easily whenever they are going to be called upon by different departments. So they can call for the raw material from the manufacturing shop, okay, and the finished products is once again stored into the storehouse. So these products are going to be called upon uh, by the assembly also, right? So that's how it is going to be taking place. So, and yes, it's going to be widely helpful and the workflow process. That is what I just explained with relevant to the manufacturing or with respect to the assembly also, right? So it's easier to identify, okay, and have the uh, make the plant much more efficiently to handle and to run the industry with a much more in an efficient manner. Right. Now, yes. Okay. So because of this, what happens if we have these? Now, why is this group technology coming into picture? Is that it is kind of uh, very much helpful where they go hand in hand with the process planning. So if we have the process planning and the group technology to come in hand, what happens is that it's easier uh, for the materials to be retrieved and to be put back after it is being machined if it's a manufacturing setup, and similarly for an assembly also. So now what happens if we take about the what are the patterns of materials, right? Then what is the materials that is present between the machines, material handling, lead time, all this can be simplified over here. So over here what happens, we need to have this group technology to be always in hand with the uh, process plan. Okay, so yes. Okay. So similar parts assembled into one family but placed in separate baskets, say for our example. So the machine setups are also frequently reduced. So the same type of parts are going to be manufactured. Probably there's a small variation in the size. Okay, but the setups are almost the same, right? So tooling can also be almost the same unless and until it's a very miniature part. So even if you take up the example of a nut and bolt, very small nuts and bolts or screws that have to be prepared if it is too small, then the process may be then only it is going to differ. But over a very long range, from in the normal bandwidth, it's going to be the same. The process and the sequence of operations will not change so much. Okay, right. Okay. Uh, yes. So here group technology once again. So every time instead of searching and starting from fresh, just like process plan, opening a new file every time and start writing from the scratch. Okay, that is also going to be avoided over here. Yeah. Uh, yes. So group technology is also going to be helpful in the design phase also. So how is it going to be helpful in the design phase is the next thing. So we have seen about the how it is helpful in the manufacturing, how it is helpful in the assembly also. Now how is it going to be helpful in the design stage? So in the design stage, when we have, say for example, let us take up a 100 cc piston, uh, engine, piston for that, and for 125 cc, 150 cc, 200 cc. For all this range, say for example, if we have the details for 100 cc, the complete design files, okay, the CAD modeling, then the analysis, what is the material, and all those things. So with that same thing, we can just uh, uh, have these data fetched from the 100 cc, make the required modifications for the 125 cc engine, and run these tests in the similar manner, whether it's going to be the structural test, the analysis, thermal analysis, vibrational analysis, and check for the uh, relevant details like stress, strain, and fatigue, life, and all those things, all the design tests. So once if we have a standard file that is already there for a similar product, we can test it once again by making the required changes, so that even in the design stage, what are the modifications that we have to do, and that can be easily incorporated. So it is all about the changing of the dimensions, but the surface finish, the material, then the number of piston rings, right? The head of the piston, all this, if it is going to be remaining the same, then not much time is required. So one such example, if we take up, is that if we see the petrol engine piston is going to be different, but some diesel engines, okay, some diesel engines will have totally a different head structure like this, right? There will be a crown at the center, uh, a higher surface, but whereas this area will be a shallow region. This is how usually the diesel engine will be there. So these particular modifications have to be made, right, for when we have the different variants. So if we are going to, we already have the data for petrol engine piston, and we have to start doing it for a diesel engine piston. Then these modifications have to be done over that, right? So it's better to copy these features, take the features from the petrol engine, but all the other requirements have to be changed right from the CAD file if it is necessary, right? So thereby, if we have the group technologies, calling upon each of these parts is also going to be easier for the design phase. Okay. So what what used to happen was that before these group technologies came into picture, is that these designers used to do all the step-by-step things uh, without knowing that we have already done for a similar part. So there they used to the time consumption in working out was too much, right? So we already have a similar, we have solved a similar problem. So which they have not retrieved it, okay, which was not retrieved, okay. So thereby these things were present in the before the group technologies came into picture, right? Okay, yes. So this is about the group technology. So here now let's see about uh, the uh, coding, classification and coding. So now we have just said about uh, how group technology is going to be, we have seen about an introduction for that. So for this, the next thing is that about the classification and coding for this. So classification of part involves, basically we want to group it into a family, right? So based on various factors which we have already mentioned, right? Like the shape, then the purpose or the application, right? And uh, based on such features, already, right? So let us have these two things as of now, right? And for this, coding involves assigning symbols to the part, okay. So of course technical names are there, but every time we cannot have the technical names to be usually used. So coding is going to identify each part uh, in it. So if I have a piston 100 cc, 200, sorry, 125, 150, 200 cc, all are pistons only. So if we have different codings, it's easy to call them. Yeah. So before constructing a coding scheme, designer has to first survey all the part features uh, for which he has to code and he has to assign it. So depending upon what the industry is going to manufacture, so first that overall idea is required for the coding to be incorporated, right? For the coding to be incorporated. So because some industries, now if you take up, there are certain industries which manufacture only pistons, but they are going to manufacture variety of pistons and piston rings accordingly. So some pistons will have only 2 piston rings, some pistons will have 3 piston rings. So based on this, first the designer has to know uh, what are all they are going to manufacture, what are the variants that they are going to manufacture. So if we take up piston itself, petrol engine pistons are different, diesel engine pistons are different, gasoline engine pistons are different, right? And in this, for these 3 categories, what are the capacities of the piston, whether it's 100 cc or 125 cc, 200 cc, that is going to be there and suitably placed one below the other. So like this, the overall picture should be there for the designer. Only then they can decide how the coding can be created for this. How codes can be assigned so that each code is being properly assigned to a particular family without any overlaps. Right. Okay. So yes. So in this, the shape, material, size, all these are very much important details to group them into family, and tolerances are not that much important. Okay, they are not that important over here for the coding purpose. Okay. Right. Yes. Uh, so yes, so based upon the shape, size, and the material, this can be used in the manufacturing, uh, that is for the machining process, what tools are to be required. All these things can also be automatically generated also. Like say for example, if a nut and bolt is going to be manufactured, then the raw material is going to be called upon. So raw material should be usually a spherical in shape, right? And what is the general material that is used for nut and bolt? So these are going to be the default inputs, so that the system can retrieve all the other data immediately. Right? Okay, so what is the sequence of machining process? What are the tools required to manufacture for this particular material and for this particular size? If these things are there, then it's going to be really easy, right? And here we can have one thing is that where this group technology is codings can be given on three different types. One is the hierarchical or monocode, that is in the way in which it has been, the codings are given. Right? The other one is the chain or polymer code, and the last one is the hybrid codes that is going to be used. Right? Yeah. Right. Okay. So these three things are going to be there on which the coding is going to be uh, followed in an industry. So it can be based on hierarchical, or it can be based on chain, and some industries, many industries go for the hybrid codes, right? Go for the hybrid codes. So let's see about the monocode or the hierarchical code. So both are the same, okay, called by different names. So here what they do is that each code number has a different meaning. Okay, so every code has got a different meaning, and the preceding number, okay, depends upon the preceding characters. What is the previous number that is present? Okay, say for example, if we have 54XXX, okay, is the hierarchical code. So the main thing is 54, okay, 54, okay, and after that 54, then we have X. So what is this actually depends upon the third digit, fourth digit depends upon actually what is the previous digit that is present. So say for example, the fourth digit of 541 indicates the typical plastic resin. So each one of them over here, 5, 4, X, X, and such things. So in that case, what we can do over here, what they say over here is that if we have 5, 4, then we have 1, and then X and X. So totally 5 digits that is going to be used. So here what happens is that each one of this digit is going to have a particular meaning. So this is going to be based upon the main family number. Then this is going to indicate the maybe say for example the type of application like nut and bolts or something like that. In that, say for example, what is the fourth series? That is the fourth subgroup. Say for example, we have M10, M12, M20 like that. Okay, and like that, what is the material it is going to be made up of, right? So every number has got a particular meaning for this, right? So all this put together will give the complete picture of what it is. Say for example, if it is a nut and bolt, okay, number 5 for a nut and bolt, number 4 for if it is going to be, say for example, M10, okay, M10 nut and bolt, okay, number 1, okay, the pitch length is 1, okay, and it's going to be the V type of threads that has to be made, and then the last digit, what is the material. So if you look at this, it is going to give all the details about the particular part, right? Okay, so in the hierarchical structure, the advantage of representing is very high. All details with very few codes can be is going to be represented. So that is the major advantage of this hierarchical codes or monocodes, right? But the only difficult thing is that preparing these codes, because it has to be assigned properly. So some case, so what will happen is that the very next thing will not be in series to this, then the very next part. Okay. So what will happen is that say for example, when we go to piston, okay, when you go for a piston thing, okay, so once again if you take up say for example 7, 3, 2 and 6, okay, so in between this for a nut and bolt, and this is for a piston, uh, for pistons this is the code that is used. We cannot always say that in that place it will always be in series. The codings will not always be in a continuous numbers. So what happens? Retrieving these numbers, remembering these codes, and finding out which are the codes that is still not yet used will be a problem with the hierarchical system, right? That is the only difficult part in the hierarchical system. But apart from that, it gives all the details once we know the code. Okay, just by looking the code and knowing the meaning for each digit, we can easily find out the entire details of that particular part. So yes, this is how the hierarchical is going to look like. So 5, 4, and next followed by another 3 digits is the main part family, that is the 5 and 4. So now if you go for 5, 4, 1, it is going to indicate they have taken up a manufacturing process, injection molding it indicates. So this particular part has to be manufactured by injection molding. So for this the material is going to be 5411. So this particular one is going to say it is going to be made up of inflammable plastic, right? And then the last digit may be whatever the shape of it, right? Okay, then so similarly in 5411, if they're going to make use of a different material, then 541, and then the next digit is going to be 2 instead of 1 because the material has changed, right? So similarly, if you go for a different manufacturing process, instead of injection molding we are going in for aluminum die casting, then it is going to go for 542 is the series, right? So depending upon the part, whether it is going to use ribs, it is going to have a different code 5421, and without ribs it's going to have a different code, but both of them are going to be manufactured using aluminum die casting only, right? So similarly for sheet metal fabrication, right? So this is how the hierarchical code is going to be functioning, and that is how it is going to have the logic, right? Okay, so we'll stop here for today.